It's a great privilege for me to introduce the next speaker. I have known Arrie, it feels like since I just came out of university. We've probably known each other for over 20 years. Arrie is an absolutely remarkable person. He, together with a small group of people in South Africa, has changed the way that theory of constraints is being applied in probably one of the most difficult industries to work in, which is mining. It's especially relevant today because mining, especially in South Africa, is being hit by a perfect storm. And the people, all the stakeholders in fact, not only management, but unions, government officials, academia, all have their hands in their hair about how do we respond to this perfect storm. Arrie and his team has been working on this for over 15 years, and it's a great honor for us that he's willing to share with us his journey through this period about what they've developed, how they've gone about testing it, what works, as importantly, what didn't work, and what they learned from it. So please help me give Arrie a warm welcome to our TOC-ICO conference.
Thanks, Alan. Alan, thank you. Ladies and gentlemen, it's a privilege for me to be here. I want to share with you 15 years of experience of implementing theory of constraints in the mining industry. For me, it was a phenomenal journey. And in this journey, I had fantastic clients, some brave people that tried to do something different. I also had some wonderful teachers, mentors, and colleagues. And I owe you a lot for being able to stand here and share a little bit of that experience with you. I want to share this in the frame of a single story, but it's not a single story. It's a story of many, many implementations that after a while we became aware of the fact that it has become a repetitive story. Similar things started happening, similar experiences came, similar failures, and similar results. And this is what I want to share with you. So I'm going to share it as a single story, but it's not. It's actually the culmination of many years of doing the same type of work. But let me create the context of this environment. In a typical deep mining environment in which many of our mines operate, it's up to 3.7 kilometers below surface, which is, well, on the Witwatersrand where most of these mines are, it's about 1.5 kilometers above sea level, which means we actually drop to 2 kilometers below sea level to do the work there. The reef width is mostly 1.2, 1.5 meters high. In some areas it goes up to 2 meters, but it's narrow reef mining. The rock temperatures down there is 50 degrees C plus, so it's absolutely essential to have good ventilation just to be able to live there. It's manual drilling of blast holes. The picture that I've got here is a fairly old picture, but in essence the work is still the same. Where people go into those areas, they manually drill the drill holes. We charge it up with explosives. Once a day, we all get out of the mine, we blast it, get the fumes out. Night shift goes in with scrapers and water jets, clean the areas to create another working space for tomorrow. And the process repeats itself every day. It's quite a harsh environment. We sink vertical shafts. On those depths, you need 2 shafts to go down to that level. And then they've got horizontal tunnels below the reef that goes below the areas. And from there, we blast tunnels upwards onto the reef from where we mine the reef. Then, after the blasted material was blasted, it gets pulled out with scrapers onto underground trains with we call it hoppers, locos and hoppers, that gets transported to the vertical shafts into silos, underground silos that feed the vertical shafts, and from there we hoist it to surface. Quite a complex, technically complex environment, extremely interdependent. You can just imagine all the people, all the material, everything we need goes down the vertical shaft, then gets distributed into the working areas. The material that we blast has to come out. People have to come out. We need special ventilation systems, special refrigeration systems to work there. Very challenging environment. Every single operation in this type of environment is unique. The design of the shafts, the design of the layout, it's adopted to the specific environment and it's unique. So you cannot really set up a standard or a blueprint, although sometimes we try. This is the environment. Here are some of the results. Of course, I present to you some of the good ones. The one mine we started with, it was doing about 6,500 square meters. That's just the square meters of the reef that was extracted per month. They lifted from 6,500 to 10,000 in about 9 months. Another mine not far from there, they were struggling to get 10,500. They lifted it to 16. Mine C was starting at 950. It was on the 9,500 on the brink of closure. Lifted it to 14,000 and eventually to 16,000. And these are the kinds of results that were achieved. The story that I will tell you is essentially that one. And another operation quite recently went from 150,000 tons a month to 200,000 tons a month. And that was done in a fairly short period of time by applying some of the breakthrough ideas. And that's what I want to share with you. So what follows is essentially their story. So let me share with you the Leeuwkloof mine story. It's quite an old mine. It was the areas close to the shafts were mined out. That was the high-grade areas. Now we moved into the lower-grade areas further away. It's almost the kind of law of diminishing returns. We're mining further and further and further away, and as we go further and further and further, the grade goes down. So the ability to make money gets worse. They reached a point where they were threatened with closure. Unless we could turn that mine around significantly, it would have to close because it was burning cash. The leadership style in this environment is autocratic dominance, with the belief the more the pressure, the better results. It's a world of finger-pointing, firefighting, blame-shifting. This particular shaft was pretty bad when it came to that. The working hours, people started before 6 in the morning. They would be in grilling meetings until 5, 6 o'clock, 7 o'clock in the evening. Long working hours. The morale was low. It was simply not working. We introduced the TOC concepts, and to my detriment, I have to share this with you. At the time, myself and the team who were engaged there, we believed we had the recipe for success. Simple, clear TOC recipe. This is how we do it. We've seen some of the successes, and we were quite confident. Jumped in there, did the initial workshops, the introductory workshops, identified the constraints, and I'll show some of what we did there. But we identified all of this, and then we did something that we learned is extremely powerful, is the daily war room or the daily engine room, where we record these measurements, we create visibility so that we can see what's happening with buffers and flow and manage accordingly. But then we did all these things, we went through all the motions, but the results simply were not there. Negligible results. And the natural thing is to do more of the same. But we intuitively knew this is not going to work. So what we did, well, let me share this with you. If this is the stoping area, this is the actual working area where people come from the underground haulages into the working area. This is where the actual blasting takes place. The number one thing you must have is a fully functional crew. In other words, the number of people with the right skills that go in there to do the work must have enough of it and the right skills, right level of skills. So we called it a fully functional crew. So we made sure that every single day in every panel, we must have the fully functional crew. But after the blast, downstream was just as critical. The stuff that was blasted had to go out, and we need to take it to the vertical shaft from where we could hoist it to surface. So it was the upstream and the downstream. I don't want to complicate this, but it does become complicated. In order to do the work, we need materials, we need explosives, we need, of course, the right people at the right time, we need timber for the roof support, we need ventilation, we need water, we need compressed air. And if this panel reaches its end, there must be a buffer of equipped panels that they can start off immediately, so that you don't stop and start, we can have a continuous operation. This is long-term, where we develop new areas, new ground where we can actually work. And this requires waste ramming, and this complicates the whole system a little bit. In the waiting place, or in the working place, we develop this kind of picture. And let me share this with you, and those of you familiar with TOC project management will recognize this immediately. If you look at the total shift time on day shift, for instance, this is the time where we do the blasting and the drilling and the support work. This is the total shift time. But now we're traveling quite long distances to get there. So there's a travel time to get to the working places. So what's left is we call the total phase shift time. And this is where the TOC brought new insight. Then we added the buffer right at the end. 25 to 30%, that's the buffer. And then we inserted the critical chain. The critical path tasks. The critical tasks that have to be done in order to do the work. And so this is the waiting place. This is the waiting place meeting. This is ensuring the safety, ensuring the safety. This is the drill preparation. This is the drilling work, the night shift preparation, charging up. And while they're doing this, we must transport the support material, build the packs. And there's the feeding buffer. Before you can start charging up, the rest of the work must be done. And we can complicate this, but this is the essential picture. But ladies and gentlemen, the key here is only after we've done this, we could determine how many people do we need, how many drilling machines, at what pressure do we need to conclude that work. And what we discovered is that the standard template did not provide enough. So we had to actually go against the standard template of efficiency measurements and change it. And we couldn't do that. The embedded systems were just too strong. We could do some winching. I don't want to go into the details. So after some time, we realized that it's not working. And then the real insight was the company was deeply entrenched in the world of local optimization. We want to optimize everything. We want to optimize the locos, we want to optimize the hoppers, you want to optimize the rock drill operation, you want to optimize cleaning, you want to optimize hoisting. So in essence, the whole system was set up as a balanced capacity chain. So whatever you improve here gets blocked by something else almost immediately. And it was like walking through mud. Everything you do, something else blocks you. And it was just this whole system of not allowing you to perform. So it was more a system problem. It was more a culture problem. And with it, the resultant people behavior, the leadership behavior, the management behavior. And that was the real challenge. How do we change that world, the culture of control, of optimizing everything? And we realized we had to challenge the mental models and the behaviors of the day-to-day operation. And the way we did it was to do a 2 days off-site exercise. I say something here, we experience our own behaviors in a game. What we did is we figured out a game where people, we take them out in nature for a 5-hour hike, scripted, with lots of challenges and exercises, and in the process, they really mess it up. They don't get there on time. They go into this blame shifting and firefighting. Everything that they do at work, they do in the game, because that's the natural default behavior. And then we literally go and sit around a campfire, and we talk about the experiences of the day. And after about 2 or 3 hours, they will tell us, you know what? What we did in the game, that's what we do every day at work. We are our own enemies. And when that realization comes, then we can ask the question, how do we do things differently? Then we presented them with a TOC frame of reference from a different angle. And at the end of those 2 days, the senior executives of this particular mine took ownership of their world. They said, we're going to get out of the mud. We're going to change things radically. We're going to go against the stream. We're going to break the system and do the right things. I think that was pretty smart. And if you can get that, then things change. Then the war room, the daily war room or the engine room, goes into a different mode. Now we start talking about tomorrow and the day after tomorrow, not about yesterday. The typical behavior in this world is we will analyze yesterday to the 3rd decimal. We will have measurements and numbers. Alan referred to this. Measurements and numbers and reports that thick about yesterday. The realization is we can do virtually nothing with it. We have to talk about tomorrow. What do we do differently? How do we build protection into the system? How do we put buffers in place? How do we enable people? And that's what we started doing. And then the real results came, because now we shifted the focus away from the constraints in the stoping areas to the logistics. And then we turned everything on its head and said, now we want to make sure that the people working inside have all the material they need for the next 2 weeks. It's here. So we put an underground store that people can just walk in, sign, and take it. No authorization from top anymore. So we gave people what they needed. We built that flexibility into the system. We started managing the long traveling distances. We introduced man carriages where we took people to their working places every single day. We delivered them to their working places, so we reduced the traveling time, and now when they get there, they're fresh. We broke the myth of double handling. For this, I will need my hands. If you've got a very long tramming distance, so you go and draw the material from the boxes, from the working places, travel all the way to the shaft, and dip it there and go all the way back. This time is an hour to an hour and a half. What we did is we blasted double rails in between, put an extra loco in. So now what happens, they pull the boxes, bring the full hoppers here, switch it to another loco, and this loco runs to the station. Can you see what we did? Instead of having that batch size, we now have 2 batch sizes of this. The rate of tramming almost went up by 60-70%. But we changed the myth of double handling. This was double handling. But the result was 50%, 60% more. Made an enormous difference. We put winches. A winch is a fairly expensive piece of equipment. We put spare winches close to the working places. So if a winch fails, you can replace it within a shift. Previously, it took you 5 days because you had to take the old winch out and take it to the store and have it replaced. We built buffers underground, a rock drill replacement system, a hopper repair shop. These are the things they started doing. And then everything changed. The production went up to 12,500 square meters, from 9,500 to 12,500. This was a major breakthrough for them. Suddenly, the pressure was off them, and we could move. And that encouraged the thinking. new mental models, more creativity. I'm not going to say much about this. And this is, in that world, a different picture, because now tramming is the key focal point. This is the stoping, delivering to it. We've got to take waste out, bring material in, bring people in, bring timber in, bring explosives in, take the reef out. And these are all in long single tunnels. That becomes quite a complicated environment. With it, we built buffers of locos, buffer of hoppers, buffer of spares, a buffer of maintenance skills. You can see the buffers all over. And then, if the buffer goes from green to yellow, you know something is maybe going wrong. Let's go and check. If it goes into red, then it means action. So suddenly, all the hundreds of actions became only a few actions. And after a while, the whole system stabilized. But then we realized the next level supervision don't always follow what we're doing. So we did the same for the next level, the first level supervisors. A one-day workshop with theory of constraints. We just used the tracking metaphor to convey the principles of flow and interdependence. And they experienced it in a new way. We again sat around the campfire, and the shift bosses figured out how to do the work in a different way. Then after 2 or 3 weeks, we discovered that some of them didn't really grasp it. And then on a suggestion from one of the members, what we did is we got all the shift bosses in a room with chairs like this. In the middle, we had a coffee table with 2 chairs, and I had an interview with one of the mine captains. Coffee shop talk, while the other guys listened in. It was just a suggestion. It made all the difference, because suddenly it wasn't instruction in their faces. They were not allowed to interfere because they were listening in, eavesdropping kind of. And we had the conversation about them and the way, what they don't understand, in a kind of an indirect way. And then the penny started dropping. Within days, we could see the improvement. Because now they figured out what they have to do. Ladies and gentlemen, it's a complex environment. You're working on a lot of different levels. It's long distances. You cannot see. So we had to rely on those supervisors there to do the real work. This brought us to a level of 14,000 square meters. By this time, this mine was highly profitable, highly successful. When you walked on that shaft, you could sense it. In the beginning, when you walked in there, you could sense there's no spirit. By this time, you could sense it. There's a spirit there. Calmness started setting in. Excellence started setting in. They knew what they were doing. A really phenomenal performance. We identified a few intensive care crews that needed special attention, and all of this started to work. Then the manager said, let's do more of this talk, because we seem to stimulate something in people's minds. And let's have another conversation. And then we introduced something that we later started calling a reflection meeting. For 1.5 hours once a week, we'll get together, no agenda, open agenda. In other words, no preparation, no presentations. The opening question for the meeting is, what do you become aware of? What's happening? Are we experiencing positive change, or are things starting to go wrong? And then we have this open conversation. And then the next stage, the one guy suggested, but we need to start thinking out of the box. Well, what does out of the box mean in their world? Something that's not in your job description. Something that's not in the standard. Let's think, what else can we do to lift the performance? And we identified something called Project 16,000. We want to go for 16,000 square meters. And we said, we will launch this in October. This was June, July. But let's have reflection meetings where we talk about this once a week. And then in September, the one guy came to us one day and he said, we're going to hit 16,000 this month. before we launched the project. Nobody had permission to do anything new. And that's when I learned the true ingenuity of people. If somebody sees something new, and it's simple and obvious, you don't have to tell them. They will just do it. The one thing that I tipped my hat to these guys was the way they broke the system. They created a buffer between themselves and the overall system. They were 20 to 30% overspent on materials. They were 15% more over on complement of people. But they were making so much money that everybody left them alone. And then they started achieving 16,000 square meters. They became the top performer in the company. They decided on an internal promotions system. In other words, we will not bring in people from the outside. We will promote our own. That created a positive vibe of itself, because now we're entrenching the new way of doing things. They got all the rewards for that group. They walked away every single quarter with all the safety rewards, all the productivity awards, everything, all the profitability awards for that whole group, to the envy of their colleagues. And then I got the dreaded phone call. One of the top executives said, "I want to visit this place." And he called me in and he sat me down and he said, "What are they doing differently? Because I've heard stories." I said, "I don't know what you've heard, but they're all true." They're breaking all the rules. And I begged him to go and visit, but don't interfere. And today I have to say he honored that. He went there and he turned a blind eye towards the crew size. Let me give you just the context. The standard template says 17 people per crew. That's 4 people on night shift, 13 on day shift. That particular, one of those crews that were doing 750 square meters instead of the 400 standard, there are 24 people on the crew. If you go into that working place, you can sense there are a lot more people here. And afterwards, the person's name is Terence Goodlace. He said, "I noticed when I went to that working place, there are a lot of people there." And I said, "I hope you didn't say anything." He said, "I didn't say anything." And what a wonderful experience this was. Breaking all the rules, breaking out of the standard templates, thinking out of the box, and changing another reality. They maintained this position for 2 years. I told you in the beginning, they were working long hours, from 6 o'clock in the morning to 6, 7 o'clock at night. About 6 months down the line, I was doing some work close by, and I thought, let me just pop in and see how it's going. And this was about 3:30 in the afternoon. I walked into that building, the lights were off. I walked the corridors, nobody there. I thought maybe they had a breakaway or a party or something. And then I went to the central control room from where they do the centralized blasting. And there was the MO sitting there waiting for, he said that still 2 crews need to clear, but they will clear in the next few minutes. They will do the blasting from surface, and then the whole process will start again. And I said, "Hendrik, where's everybody else?" He looked at his watch and he said, "Well, what do you mean, where's everybody else? They've gone home." And then I discovered the manager of that shaft, if he caught you still working there just after 3 o'clock, he'll chase you home. He will ask you, "Have you got a family?" "Yes, sir, I've got a family." "Go home." "Yes, but what about this?" He said, "You can do that tomorrow." So, lights off at 3:30. What we saw here is the world of superflow in a spirit of calmness. They knew they were going to get their call. They knew exactly what they were doing. Everything was really working. If I may use the word, I don't think fully anti-fragile, but very close to it. But as with so many good stories, there's a sad part to this. The manager and the mine overseers who showed these successes were promoted into other parts of the business. A new manager was appointed from outside. And on day one, he walked in there. He said, I hear you are the big guys. You've got a chip on your shoulders. You think you know how to mine. From tomorrow, we will mine my way. The first thing he did is he stopped. He closed all the underground stores because it was too much money, too much cash. He introduced strict cost and budget controls. He stopped the tramming shuttles, cut the crew sizes back to standard. And before you know it, the shaft was back to 7,000 square meters. Very sad story. And it's not nice for me to end up with this. But this happens too often. So this is the story of the Leeuwkloof mine. I'll get back to this picture. What I want to share with you now in the last 10 minutes is the approach that we follow when we're engaging with a mining environment. This will normally take 1.5 hours to 2 hours. I'm going to do it in 10 minutes. With your theory of constraints background, I'm pretty sure you'll understand exactly what I'm doing. You can ask me afterwards, but I need to show you this and then bring the real insight. A mining environment is a complex environment. And this is just a picture of a complex system where this is the primary production flow chain. And you know better than me, your primary flow chain needs maintenance, it needs spare parts, it needs purchasing, we need training, all of those things. And those are all the bubbles around it. But if I want to explain the TOC concepts, allow me to just take one portion out of it. And I'm just going to select the center portion of 6 resources. Let's take it to the next page. And normally, if I show this picture to any audience in the mining environment, and I say in that picture, the 10 there is 10 tons an hour on average. The 15 is 15 tons an hour, or units per hour if you want. So that's the inherent capacity of each of those links in the chain. Got the picture? Linear chain, different capacities. Then the obvious question, do you think this is a good design? And most people will shake their heads and say no. And I will ask them, well, how bad is it? Sometimes somebody would say, the person who designed that chain must go back to university and get his money back. This is not a good design. And then the obvious question, what's wrong with it? And some people will say, but this thing has got a bottleneck in there. This chain can only produce 10 tons an hour on average. While over here, there will be a lot of idle time. This thing is totally out of balance. And then I ask them 2 scenarios. If you want to produce more, if there's a lucrative market, the prices are good, and you've got enough money, how will you improve this chain? And the typical response is, we will start there because there's the bottleneck. Let's de-bottleneck the system. Take the 10 and lift it. To what level? Some would say 12, 13, but most will say 16. So you'll take the 10, you'll make it a 16. The moment you do that, the 12 will be the new bottleneck. We'll take the 12 and take it up to 16. The 13 will become the new bottleneck. You follow my process? Where will we end up? We will end up with a chain like this. And then they will typically say, this is much better. How much will this chain produce? 16. And I keep quiet. But there's another way, and unfortunately this is happening right now. If we're in a market downturn and we cannot sell more than 10, what will we do then? We'll right-size the business. We will cut the fat. You know those terms. There are more better terms than that. And we'll take this chain and cut out all the fat, and we'll create the 10-10-10 balance capacity chain. And people would say, well, these 2 at the bottom are much better designed than the top one. And then the real challenge from a TOC point comes and say, well, how much will this chain produce? And let me use the 10-10-10 because it's just easier numbers. Let's just look at 2 resources in interdependence. If this can do on average 10 tons an hour, how much will it actually do? Well, sometimes a little bit more, sometimes a little bit less. Average out. Just by the way, you know that if you use the word average, most of us automatically see a normal distribution. That's the default picture in our minds, but it's not the true picture. Because if I talk about 80% availability, it means there's a 20% of zero in there. If it breaks down, it produces nothing. If it's if it's undergoing maintenance, it will produce nothing. I'm not going to go there now. But the key question is, how much will these two produce in interdependence? If the purple one fluctuates like this, and the green one fluctuates in a different way because it's a different resource, what will we see there? Well, at some stage, the purple one might produce only 8. It will pass only 8 to the green one, and 8 will report there. A little while later, this one drops to 4. It will block that one from doing more than 4, and only 4 will report there. So the output of those two will follow the law of the weakest link. And the weakest link at any given point in time will determine the output. So the output of those two will follow this curve. And immediately you can see it significantly below 10. But let's expand it to 6. And now each of the 6 has its own variation. Let me give you a sneak peek. It will produce only about 5. You can see I've over-exaggerated just to make the point. Then the obvious question, which color is the bottleneck? And people will sit and stare at me like this. And somebody will vote for purple. And then I'll get a vote for red. And then I'll go get a vote for green. And I said, come on, give me a vote for turquoise. The color here is a little bit different. No, turquoise is not the bottleneck. And then the question, where will the bottleneck be tomorrow if we are here now? And then, like one manager said, I don't care. We're living in the 21st century. I've got a cell phone. Whatever happens, I'll call the responsible person who will fix it. Do you hear the culture of firefighting? Excellent super efficient firefighters. Blame shifting, firefighting, finger pointing, that's the culture. And then the question, did you realize that that design can only produce this? The balanced capacity design is the source of firefighting, finger pointing, and blame shifting. And that's the realization in the mining industry. Big problem. So this chain will produce only 5, the 10-10-10 balanced capacity chain. And then may I quote Dr. Eli Goldratt's, one of his famous statements. If a company tells me they experience moving bottlenecks, my response is, you have no bottlenecks. And most of your resources have at least 30% spare capacity. Sometimes he said 50. Do you recognize that picture? That's the world of balanced capacity. Let me take this to its full conclusion. If 6 of these on 10-10-10 will produce 5, how much will this system produce? If you're lucky, 4. How long will top management man and equip you for 10 and you produce only 5? 4. Inevitably, the cut will come. Cut 20%. We'll cut everything to 8 because that's the way we do it. The system will produce 3.2. Then you cut it to 6 to produce 2.4. Then you'll cut it to 5. It will produce 2. And then you'll declare it as an unprofitable operation. Close it or sell it. And then I hear Dr. Goldratt's words echoing in my mind. The closer you are to balanced capacity chain, the closer you are to bankruptcy. And for many people, this is a revelation because they've never in their world thought about it like this. Because all the systems, and now I'm criticizing the mining industry and I apologize for it. All the systems, all the measurements, all the KPIs, everything we do in the mining industry is aimed at this. We want to optimize everything. It's a perfectly balanced capacity environment and culture of control. And ladies and gentlemen, that's the core problem. So we start off with something like this in our industry, and then we derive at this solution without thinking about the consequences. And then we go one step further. We systemize it. We change the little bubbles with little black boxes, and it becomes a system of black boxes and blueprints and standards. And it simply doesn't work. The picture that I want to use is this one, and maybe you cannot see it that well. It's Gulliver in Gulliver's Travels. It's the giant, that's the money-making machine, is tied up with hundreds and thousands of little ropes, and it simply can't move. And now we come with TOC, we try within that world to do something different. And this is where the real insight came. Unless we do something about that thing, it's not going to work. You can play around in that environment until you're blue in the face. You'll just hit one wall after the other, and you'll be walking in mud all the time. And every now and then we get some brave managers, some brave leaders that says, this is not what we want, we have to do something else. And then we present theory of constraints. But before I go there, remember this statement? Do you want to make money, or do you want to show off efficiencies? One manager looked me straight in the face and said, but it's the same. I said, no, it's not the same. Two different worlds. So what does the world of making money look like? And I'm doing this as a short version. If this is your constraint, know where your constraint is. Exploit it. Squeeze everything out of it. Zoom in on it. Focus on it. But when it comes to the interdependence in the chain, put a buffer of work in front of it to protect it against starvation. Put a space buffer behind it to protect it against blockage. Free up the constraint so that the constraint can move freely. And I don't have the time for the full logic here. But in order to have a buffer there all the time, it means you need protective capacity upstream. If upstream does not have more capacity than the bottleneck, it will never be able to build and maintain that buffer. We can go through the logic, but ladies and gentlemen, you need at least 20% there. At least 20%. So I've got 20% more capacity upstream, and once the buffer is full, they have to stop. And guess what? The moment you stop and you sit down, who walks past? The manager. In 2 weeks' time, it's budget meeting. What will he tell me? You want all these people? Every time I walk through there, you're sitting down, you're doing nothing. And then the cut will come, we will create the 10-10-10 chain again. We're back to square one. So the senior management must understand conceptually where we're going. I'm pushing you too hard now. I apologize, but not really. The same is for downstream. I need protective capacity downstream. So this is the world of optimized flow. And suddenly, it's only the bottleneck. The miracle that happens here, now the whole chain is governed only by the rate of the bottleneck. And if I take that to the previous picture, and I put the buffers in there, it means it's now the output of the red curve, which is this one here. That will be the output of the whole system. And suddenly you can see, just visually, we're talking about 20 to 30% more. By just putting in the right buffers, building in the right protection, ensuring that you've got enough capacity to sustain those buffers, will take you into a totally different space. And ladies and gentlemen, this is what we do. And then, if you want to, well, this is Dr. Goldratt again. If you want to make money, most of your resources must be idle from time to time. This is a one-sentence summary of what it's all about. And then the realization, in any serial production chain, you can optimize only one link. So kiss goodbye the world of optimization. I was so proud of one mine manager because we went for a visit to another mine to look at a system. And the guys asked him, how do you do your optimization? He was sitting next to me. He said, we have abandoned the concept of optimization. I sat there, I thought, where did that come from? And the guy asked him, what are you talking about? He said, no, ask him, he taught me this. and then you can start a long and very interesting conversation. But in the mining industry, we are fixated by efficiencies and local optimization, optimizing everything. It's taking us nowhere. Strategically, where do you want your weakest link to be? I think that's our next conversation. In a given situation, we do with what we have. But if we have the chance of designing a new mine, we decide that up front. I have to show one cloud just for all the TOC people in the room. The big challenge of each and every manager is to make more money now as well in the future. And in order to do that, we have to control cost, and at the same time, we have to maximize flow. You know this part. Traditionally, in order to control cost, we created the 10-10-10 balance capacity chain. And traditionally, in order to maximize flow, we created the 16-16-16 balanced capacity chain. I hope you see now that they suffer from the same flaw. And the TOC drum buffer rope solution actually breaks that conflict and creates a new paradigm that will give you both. And if the managers can see this, we free them up to start thinking differently about their world. I'm finishing off with this 2 slides. Taking it to its full conclusion, there's your bottleneck. Maybe we go overboard, and I don't apologize for that, but we buffer everything around it. We buffer the flow, we buffer material, maintenance, everything. So that that constraint in that system can really perform. And then we buffer, we'll go one step further, and we buffer the full primary production flow chain so that all the services have enough capacity so that nobody in the primary production flow chain will wait for any service. This is a bit of a paradigm shift. But those who do it, or have the bravery to do it, they really make it work. I want to finish off with this picture. What we do in the daily war room is to create the change in culture. The objective is to change from this world, and you now understand exactly what I mean. It's freeing up the giant. And just metaphorically, if you want to free up that giant, all you have to do is free one hand and energize the giant. He will free himself after that. Just get him to move and experience some freedom. And just help them to protect them a little bit from that system. Because that system will retaliate. I can tell you beautiful stories about how that system does it. We want to move from the world of control, the world of KPIs, cost world, the world of managing by numbers, to the world of enablement, the world of flow of the system as a whole, managing the constraints, buffer management, the throughput world, and we can continue. And the daily engine room or the daily war room is to take us from this world into the world of, from the tie-down giant to the world of Formula One. And we use these pictures these days. And say, guys, what we do on a daily basis is to shift from this world into that world. And it's a tough journey. It doesn't happen often. Thank you.